What is artificial intelligence? Well, an easy answer is it's if computers are intelligent, if they do something which is intelligent. But that leads us to the question, what is intelligence? Well, it's somehow a capacity which we humans have. But that's too vague, that's too general. Let's be a little more specific and distinguish different types of artificial intelligence to better understand what one can reasonably call artificial intelligence. But first here, we see humans as a reference point for performance. That's what I already mentioned. Intelligence is something which we usually attribute to humans. And now artificial intelligence, if computers, in a sense, mimic humans in this characteristic. And then if we look at us humans, then we might think it's about our thought processes and the conclusions from these thought processes. So we could say it's artificial intelligence if a computer does what we humans do in our thinking. So it's about cognitive modeling there. But then it might not be about our human thought processes and the conclusions, but it might be about our behavior. In the end, we don't really know our thought processes. I mean, we have a level of introspection, but you don't know what somebody else is thinking, and we collectively as humans from our scientific knowledge don't fully understand how human thinking works, how our brain really works. So is it really reasonable to take the inner workings of our brain as benchmark for what we call artificial intelligence? Or shouldn't it be rather about the human actions, so about our outward behavior? And then, for example, the Turing test would be an approach to measure the performance here, to see whether a computer is artificial intelligence, if it can manage to have a conversation like a human would, no matter what the inner workings of the computer or the brain looks like. So you see this difference between whether we try to model the thought process or the behavior of humans. But then is the human the right benchmark? Or wouldn't be rationality the reference point for performance? Because we know that we humans are boundedly rational, in parts irrational. And why should we build computers, model computers in a way that they mimic our fallacies, our biases? Why shouldn't we build computers which are better than us humans? So we could think that rationality is the reference point for performance. Then it would be about rational thinking, if we again at the level of thought processes. But then we could as well move it to the level of behavior and say, well, it's about rational action. Now you have 4 different conceptions what artificial intelligence could be. When should we call a system artificially intelligent? If it's like human thinking, or like human action, or like rational thinking, or like rational action. There's no right or wrong answer on that, and there's no consensus on that. You see it from the different references in these different fields, that they are also supporting each of these different arguments. And on the one hand, it's a philosophical question, which of you consider the best answer? On the other hand, and from my perspective a little more importantly, it's about the application scenario. It's about why would we want to have artificial intelligence system? What should their task be? What is their purpose? And from that you can derive which of these different definitions makes most sense. So overall, there's a variety of different interpretations and definitions of what artificial intelligence could be. What is your personal perspective? Which of these types is the most reasonable perspective? Which should we aim for? Independent of these perspectives, artificial intelligence is a broad umbrella term covering many different technological approaches. To name just 2 prominent ones, it's logic-based systems and machine learning, which both contribute to artificial intelligence. So logic-based systems are about artificial intelligence techniques based on a set of axioms and mathematical logic. So you write out a set of rules, for example, on the world, and you make a set of assumptions on which entities are there in the world, and then the computer can do inference by applying the rules to the set of assumptions to the data, and thereby it then produces new knowledge or behavior and so on. But that has nothing to do with the computer learning, but you give it all the information, all the rules and so on, and the computer just applies the logic and mathematics to that. And that is one form of artificial intelligence. Then another is machine learning. This is about artificial intelligence techniques that use statistical methods to improve performance on a task through more data, through more experience. So to be a little more formal, let's take a definition of Mitchell 1997 on what machine learning is. A computer program is said to learn from experience, E, with respect to some class of tasks, T, and performance measure, P, if its performance at task T, as measured by P, improves with experience, E. A little formal, but if you read it 2 or 3 times, then you'll get the interconnection of these different E, P, T, and so on. And what you see in there is a rather narrow definition of what this machine learning is. It's more narrow than the conceptions of artificial intelligence, which I had on the previous slide. So it's task specific and it's performance measure specific on that task. Think back about this. What is a performance benchmark? Is it rationality or is it humans? Well, these are different performance measures. And so you need to define that first and be a lot more specific than only say it's about rational or it's about humans on the performance measure, on the specific task which a system should be good on. But then if it gets more experience, so sees more data and learns from this data in the sense of improving its performance on that task, then we talk about machine learning. And these are 2 prominent forms of artificial intelligence. Probably at the moment, machine learning more at the forefront of the hype than the logic-based systems, but there are other forms as well. So don't make the mistake to think artificial intelligence and machine learning and then deep learning as a subset of machine learning would be all identical. These are different concepts, one more abstract, one more specific example. And now where does this lead us? What is the outlook? Where will artificial intelligence go? Well, on this slide I have 3 very stylized perspectives. One is, to my interpretation, but also I think many people agree with me on that, a too pessimistic view. That would be that the next AI winter is already upon us. Well, that we saw a boom in the hype around artificial intelligence, machine learning, especially deep learning, with all the new data, with the computing power, with improvements in the algorithms and so on. But that we're now entering a new AI winter, like we've seen many of these AI winters over the last decades, where the hype slows down, where we have stagnation in terms of technological development, a stagnation in terms of market penetration of the algorithms. I don't think that will be the case, but it might be. On the other hand side, we have another scenario. It's too optimistic in the sense of the capabilities of artificial intelligence. So it's about a super intelligent artificial intelligence, which is a solution to all problems, but thereby also might create new problems. This is about a technological singularity where at one point in time, and some people think it's close to us, my personal opinion would be that it's rather far away, if we should reach it at all, that we will have a general artificial intelligence which is on the level of a human, which exceeds human capacities and then can further develop itself and thereby become super intelligent. Not only on a narrow task with respect to a narrow performance measure, but basically on all tasks. And this has, as you see in the text, great opportunities for humankind, but also, as you see in many science fiction movies, it might have detrimental downsides for us. Well, the most realistic scenario is somewhere in the middle. Artificial intelligence cannot do everything for the foreseeable future, but it will have an impact on all industries, on all businesses, on all our lives. It already has so on most industries, most businesses, most of our lives today, and probably this will further permeate with these AI systems becoming better and better in narrow niches, so that we talk about narrow artificial intelligence, but then don't come to the level of a general artificial intelligence, a broad artificial intelligence.